Then we discuss the monetary approach, implications, and evidence. Let's think about the question: what price would exchange rates follow from now on if prices were flexible and PPP held? Assume that US and European real income growth rates are identical and equal to zero. Also, the European price level is constant and the European inflation is zero. Based on these assumptions, we examine two cases. Case 1, a one-time increase in the money supply. A. There is a 10% increase in the money supply M. B. Their money balance M over P remain constant because their income is constant. C. These last two statements imply that price level P and money supply M must move in the same proportion. So there is a 10% increase in the price level P. D. PPP implies that the exchange rate E and price level P must move in the same proportion. So there is a 10% increase in the exchange rate E. That is, the dollar depreciates by 10%. Case 2. An increase in the rate of money growth. The US money supply grows at a steady fixed rate mu. Then, at time t, that the United States will raise the rate of money supply growth to a slightly higher rate of mu plus delta mu. A. Money supply M is growing at a constant rate. B. Their money balances M over P remain constant as before. In figure 3.6, before time t, money, prices, and the exchange rate all grow at rate mu. Falling prices are constant. In panel A, we suppose at time t, there is an increased delta mu in the rate of growth of home money supply M. In panel B, the quantity theory assumes that the level of real money balances remains unchanged. At time t, if real money balances M over P are constant, the money M and prices P still grow at the same rate, which is now mu plus delta mu. So the rate of inflation rises by delta mu, as shown in panel C. PPP and an assumed stable falling prices level imply that the exchange rate will follow a path similar to that of the domestic prices level. So E also grows at the new rate, mu plus delta mu, and the rate of depreciation rises by delta mu, as shown in panel D. Then we discuss money, interest rate, and prices in the long run, a general model. The trouble with quantity theory we studied earlier is that it assumes that the demand for money is stable, and this is implausible. In this section, we explore a more general model that allows for money demand to vary with the nominal interest rate. We consider the links between inflation and the nominal interest rate in an open economy, and then return to the question of how best to understand what determines exchange rate in the long run. All else equal, a rise in national dollar income will cause a proportional increase in transaction and hence in aggregate money demand. All else equal, a rise in the nominal interest rate will cause the aggregate demand for money to fall. MD is equal to Li times P times Y. MD is mean demand for money. Li is a decreasing fraction. P times Y is mean nominal income. Dividing by P, we can derive the demand for real money balances. MD over P is equal to Li times Y. It means that demand for real money is equal to decreasing fraction times real income. Figure 3.11, panel A shows the real money demand function for the United States. The downward slope implies that the quantity of real money demand rises as the nominal interest rate I dollar falls. Panel B shows that an increase in real income from Y1 to Y2 caused real money demand to rise at all levels of the nominal interest rate I US dollar. The money market is in equilibrium when the real money supply equals the demand for real money balance. Here is capital M over capital P is capital L of I times capital Y. With two relationships in hand, PVP and UIP, we can derive a powerful and striking result concerning interest rates that has profound implications for our study of open economy macroeconomics. We use a subscript E to denote such expectations. Equation 3.2 is recast to show expected depreciation and inflation at time t. So the expected rate of dollar depreciation is equal to expected inflation differential. Expected rate of dollar depreciation is equal to expected inflation differential. And expected rate of dollar depreciation is equal to net dollar interest rate minus net euro interest rate. Because the left side of the previous two equations are equal, the right side of must also be equal. Thus, the nominal interest rate differential equals the expected inflation differential. All else equal, a rise in the expected inflation rate in a country will lead to an equal rise in its nominal interest rate. This result is known as the Fisher effect. The Fisher effect predicts that the change in the opportunity cost of money is equal not just to the change in the nominal interest rate, but also to the change in the inflation rate. Rearrange the last equation. We find I US dollar minus pi US expected is equal to I Europe minus pi EUR expected. When the inflation rate pi is subtracted from a nominal interest rate I, the result is a real interest rate R. The inflation adjusted return on an interest rate bearing asset. So RUS expected is equal to R EUR expected. This remarkable result states that following: if PVP and UIP hold, then expected real interest rates are equalized across countries. This powerful condition is called real interest rate parity. Implies the following: arbitrage in goods and financial market alone is sufficient in the long run to cause the equalization of real interest rates across countries. In the long run, all countries will all share a common expected real interest rate. The long-run expected world real interest rate denoted R star. So RUS expected is equal to REUR expected and equal to R star. We treat R star as a given. Exogenous variable, something outside of the control of a policymaker in any particular country. Under these conditions, the Fisher effect is even clearer because by definition. Thus, in each country, the long-run expected nominal interest rate is the long-run world real interest rate plus the country's expected long-run inflation rate. For example, if the world real interest rate is R star is equal to 2%, and the country's long-run expected inflation rate goes up by 2 percentage points from 3% to 5%, then its long-run nominal interest rate also goes up by 2 percentage points from the old level of 2 plus 3% is equal to 5% to a new level of 2 plus 5 is equal to 7%. Now that we understand how the nominal interest rate is determined in the long run, our general model is complete. This model differs from the simple model, only by allowing L to vary as a function of the nominal interest rate I. Exchange rate is equal to the ratio of price levels equal to relative nominal money supplies divided by relative real money demands. It is only when nominal interest rate change that the general model has different implications, and we now have the right tools for that situation. We now examine the forecasting problem for the case in which there is an increase in the US rate of the money growth. We learn at time t that the United States is raising the rate of money supply growing. We learn at time t that the United States is raising the rate of money supply growth from some fixed rate mu to a slightly higher rate mu plus theta mu. How will the exchange rate behave in the long run? To solve the model, we make an assumption that US inflation rates and interest rates are constant before and after time t, and focus on the differences between the two periods caused by the change in money supply growth in figure 3.14. Before time t, money, prices, and the exchange rate all grow at rate of mu. Foreign prices are constant. In part A, we suppose at time t, these earn increased theta mu in the rate of growth of home money supply M. This causes an increased theta mu in the rate of inflation. The Fisher effect means that there will be a theta mu increase in the nominal interest rate. As a result, as shown in part B, real money demand falls with a decreased jump at time t. If real money balances are to fall when the nominal money supply expands continuously, then the domestic price level must make a discrete jump up at time t, as shown in part C. Subsequently, prices grow at a new higher rate of inflation, and given the stable falling prices level, PPP implies that the exchange rate follows a similar path to the domestic price level, as shown in part D.